In this video, we're asked to write the piecewise function given a graph, okay? And this can be a little bit tricky. So let's start just by saying maybe f of x equals, and then notice that there are two pieces to this piecewise function. And so you'll have maybe a open curly bracket like this with one piece up here, one piece down here. Now, the first thing you want to check is what is your domain doing? And so ours looks like it's split right here at 0. So on our x-axis, it is at 0, where I have one piece going left and the other piece going to the right. And specifically, this red piece, you might say, it's going to be when x is less than or equal to 0. How do I know it's less than or equal to? Well, because it's going left, so it's less than. It's a closed dot, so it's going to get the equal to sign. All right, the other one, it's going to be when x is greater than 0. When x is greater than 0. Again, that's not going to have the equal to sign because it's an open dot. All right, the more important part, though, is what is our graph doing? And so here you can check to see if I were to write this part in red in the form y equals mx plus b, plus b, our b is where we want to start. In this case, it's down 1, 2, 3. So I can replace this with, since it's down 3, a negative 3. All right, and the other part, remember, m stands for your slope. You'll have grid lines probably on your graph paper. Since I don't, I drew out little dots to show what's happening here. And to me, this is going down 2 and to the left 1. Or if you were to continue this, if I look at maybe this point to this point, going how it's supposed to the right, this would be going up 2 and right 1. So this is going to be a positive 2 over 1x, or you might just say that this would be 2. All right, so if I were to list this out over here, remember f of x means y, so we don't have to write that. So we already have our equal sign. So I'm just going to say 2x minus 3. 2x minus 3 when x is less than or equal to 0. And then the part in black, switch my markers here. This time, well, this is clearly the square root function. However, it looks like normally it would be here at 0. It is shifted up 1. And remember, when we shift something up, we add it to the end of our function. So this would be the square root of x, and then at the end of it, I can say plus 1 when x is greater than 0. All right, so that's given this graph. Let's see if we can try another one when we write the piecewise function. All right, this next piecewise function clearly has 3 different pieces, and I tried to do them in different colors for you so we can tell what's what. But let's see if we can figure out what's happening with our domain. All right, since it needs to be split up kind of in 3 different parts. The first part here on the left, it looks like it starts when it's at negative 2 and goes to the left, or when it's smaller, or you might say less than negative 2. So in that top piece, on the side over here, I'm going to say if x is less than 2. Negative 2. Because it's smaller when negative 2, and I know it's less than because it's an open dot. The next piece is going from negative 2 until 1, 2, 3. All right, now the way you write this is typically you put your x in the middle, all right, and then we're going to use less than signs. Notice that the one on the left has the closed dot, so I'm going to put a less than or equal to here, and then you'll just write the numbers on either side, on the left and on the right, that we use. In this case, negative 2, and on that case, it's going to be 1, 2, 3. So I would say if x is between negative 2 and 3, and that's how you would write it. I might move my if out of the way because we'll need that later. All right, the last part here in black is going to be when x is greater than or equal to 3. Again, 1, 2, 3. It's a closed dot, so it's going to have that equal to sign with it. So I'll say if x is greater than or equal to 3. Okay, so that's what's happening with the domain, but what's happening with the actual pieces? Well, let's look at it. This one in purple, it looks to me like it's just a horizontal line that goes straight left. All right, and if that happens from negative 2 on to the left, it is down, it looks like at negative 1. And so you might just say that this is the horizontal line, y equals negative 1. Well, we already have our y, f of x equals y. And so I would just say a negative 1 right there in my top piece. And it's restricted again when x is less than negative 2. All right, for my middle piece, I need to think what kind of a function gives me a v. All right, this has to be written all in one line. I can't have one going this way and the other one going that way. And remember, the one that does that is actually our absolute value function. Okay, so this is going to be the absolute value of x. Is it shifted at all? No, it has its vertex, if you will, right here at our origin. And so it is between -2, and 3 when it's the absolute value function of x. All right, our last one is going to be right here. And it looks to me like this has a slope. It goes up 1, 2 over 1. And so if I were to write this in the form y equals mx plus b, my slope is 2 over 1, or you might just say 2, okay? But the b is where it crosses my y-axis. That's not going to happen until it gets down here somewhere. And so you might have to follow this backwards, you know, on your graph paper. Let's try it. So it's going to be down 1, 2 over 1, down 1, 2 over 1, and down 1, 2 over 1. So it looks to me like it hits right here at -4. Okay, now again, it's not on the graph there because I have my absolute value function taken up when I'm here at 0. But it does have to cross my y-intercept in order for me to say this. So it would be the line y equals 2x minus 4, because that hits right there at -4. So up here again, y is the same thing as f of x. So I just say equals 2x minus 4 if, again, x is greater than or equal to the +3. And that is how you write piecewise functions given a graph.